Today we're going to continue looking at section 8.5 and 8.7, so factoring a trinomial with the lead coefficient of 1 and special cases. So our objectives, we're going to factor trinomials with a lead coefficient of 1, we'll factor perfect square trinomials and the difference of two squares. So if the directions ask us to factor completely, remember, very first thing we have to do is we have to look for a GCF. So are there any numbers that they all have in common, or are there any variables that they all have in common? The fact that this first example says x squared, when there's really a 1 in front, then there's not going to be a number that they all have in common besides 1, and that's not going to change the problem. So then I'm really looking for variables. Do I have a variable in every single term? Because the 60 does not contain an x, there is no GCF. So it's always a good idea to check, because sometimes and eventually there will be a GCF. But in this case, there isn't. So that means that we can follow the pattern of what multiplies to the last number, but adds to the number in the middle. All right, so I'm going to make a table. I need it to multiply to positive 60, and it needs to add to positive 23. So there are several different ways for us to multiply to 60, but we need to try to get to 23. So hopefully we're okay with understanding that, yeah, 1 times 60 is going to multiply to 60, but those two numbers will not add up to 23. If we have 2 times 30, once again, those two numbers, if I add them, will not add up to 23. If I have 3 times 20, well, 3 times 20 is 60, and notice here, 3 plus 20 is going to get me that middle number of 23. So it might take you a couple of tries to find those correct numbers, but you'll get there. Just build a table and you'll make it work. So remember, I want to have two terms being multiplied together. Because we are dealing with an x squared, I'm going to start each of my parentheses with an x. Because everything is positive, one of them is going to be with a positive 3, and one of them is going to be with a positive 20. If you put the 20 first and the 3 second, that is perfectly fine as well, because multiplication, the order doesn't matter. So this would be my answer. And remember, you can always double check that this is your answer by multiplying it back out and seeing that you get your original problem. So if I was to do the distributive property to multiply, I'm going to break up the x plus 3 and distribute it to the x plus 20. So this is how I would set it up. Notice that if I distribute the x, we'll get x squared plus 20x. If I was to distribute the 3, we'd get 3x plus 60. We have a couple of like terms here in the middle. That would then turn into x squared plus 23x plus 60. So notice that the answer that I got when I multiplied was the answer that we had, or our problem, from our original. So that's why I know that I've checked it and it works. So that's why what I have circled is indeed my answer. All right, moving on to the next one, x squared plus 10x plus 25. Well, I don't have a GCF because, once again, if there's just a 1 in front, no numbers in common. If there's no variable with the 25, then I don't have a GCF. So then what multiplies to 25 but adds to 10 is going to get me my answer. Everything is positive, so that's nice. I get to keep all my numbers positive. Hopefully we recognize that 5 times 5 gets us 25, and if I add those two numbers, I'm going to get 10, which is the number that I want. So we're going to have an x plus 5 times an x plus 5. And really what this is a perfect square trinomial because I have the same exact thing in parentheses. Another way to write it would be x plus 5 quantity squared because there's two of the same thing being multiplied together. Okay, I would just leave it as the binomial times the binomial. You don't have to write it as quantity squared, but I want to tell you that that's where in my objective, when we were talking about perfect square trinomials, that's what it represents. You end up with the same binomial being multiplied by each other, so it's technically that one binomial quantity squared. In number 3, we've got x squared minus x minus 30. There won't be a number in common. They don't all have a variable. There is no GCF. If it helps, remember there is a 1 with that x. So I want to find numbers that multiply to negative 30 but add to negative 1. So if I need to multiply to a negative number, that means that I need to have one of each sign. So one positive and one negative. Because I need to add to a negative, we have to figure out which number is going to get us there. So we're probably going to want to deal with numbers that are really close to each other. So if you look at your multiplication chart, maybe you'll notice that 6 times 5 gives us 30. So remember, one of them has to be positive and one of them has to be negative. Let's see if the 6 is positive and the 5 is negative, if I'll get that negative 1 in the middle. Well, 6 plus negative 5, that's going to give me a positive 1. So I got the correct number, but not the sign in front. So that means all we have to do is flip the signs around. If I have negative 6 and a positive 5, and I add those, that's where my negative 1 comes from. So those are the two numbers that I need to put in my final answer. So remember, with our two binomials being multiplied together, we would start each of those with x. And so then I want the 6 to be negative and the 5 to be positive to state what my final answer is. In problem number 4, we have x squared minus 9x plus 18. I don't see a GCF because they don't have a number in common. They also don't all have a variable. So I need to find numbers that multiply to the last number and add to the number in the middle. I need to multiply to a positive 18. So if we're thinking about multiplying to a positive, we have a positive times a positive or a negative times a negative. Notice that because my middle number is negative, I'm probably going to want to go with negative signs. Two positives will not add up to a negative. So let's make sure that we understand that both of my numbers are going to have to be negative. If I need to add two numbers to be negative 9, well, hopefully you recognize that 9 times 2 or negative 9 times negative 2 is not going to work in this situation. Another way to multiply to 18 would be negative 6 times negative 3. Notice that when I add those two numbers, I'll get the number in the middle that we're looking for. So negative 6 and negative 3 are going to be a part of my final answer. So we'll want an x minus 6 for one of my answers times x minus 3. All right, if I look at this next example, x squared minus 256. Because there is a 1 in front, I know that they're not going to have any numbers in common. Because there's no variable with that 256, I have no GCF. But remember, we talked about this. When there are only two terms here, I'm missing an x. I'm missing that middle term. So we can really write this as x squared plus 0x minus 256. All right, so if I want to try to figure out what is going to multiply to this negative 256 but add to 0, we have to recognize that if we're adding to 0, that means that we are going to want the same number but opposite signs. Okay, that's why this type of problem is called a difference of two squares. Two squares means that these numbers that we're dealing with are perfect square numbers. So to help us out, if we were to take the square root of 256, that'll give us the same number that you multiply by itself to get that. Well, the square root of 256 is 16. To multiply to a negative 256, one of those 16s has to be positive, one of them has to be negative. Notice that then if I add them up, it will get me that 0 I was looking for. So negative 16 and positive 16 are going to help me get my answer. We'll start each of our parentheses with an x because we have x squared to begin with. One of the parentheses needs a negative 16 and one of them needs a positive 16. And that would be my answer. Last example here, we've got x squared minus 121. So I don't see a GCF, I don't see a middle term of x, so we can think of this as x squared plus 0x minus 121. So I'm looking for numbers that multiply to negative 121. If I need them to add to 0, I want it to be the same number but opposite signs. So like we just talked about, this is a difference of two squares, meaning perfect squares, square roots. If I was to take the square root of this number, I would see that I get the number 11. That means make one of those numbers a positive 11, make one of them a negative 11. That will definitely multiply to negative 121. And if I add those two numbers, I'll get that 0 in the middle that I was looking for. So my final answer will have an x plus 11 times an x minus 11. And that would be my answer.